Well, hello. Today we're going to learn about the different methods that are found in the math class. The math class is a static class. You do not need to create an object to use any of the methods. You just use the class name math dot and then the name of the method, and you can invoke the methods that are within the math class. Alright, to get it started, on Schoology you will find math examples .java. This is our starter program that we're going to fill in. Okay, for this class we need some import statements. So import java.lang.math. I want you to know that you do not have to import the math class. .lang is automatically imported, available to all classes. Alright? But we are going to use the keyboard today, so we need to import the scanner class. Import java.util.scanner. Alright, so those are our two import statements. They don't have to go above the notes, but they have to go above the class header, which is line 19, public class math examples. Alright, so let's look at the different methods in the math class. We have a static int absolute value. So if we put an integer in the parentheses, it will take the absolute value of it and it will store it in an integer variable that we define. Now, static double absolute value double. So if we put a double in the parentheses, notice these two are spelled exactly the same, which means that this method is overloaded. So it knows better, it knows which one to use. If you put a double in here, it uses the double method. If you put an integer in here, it'll use the integer one. Okay, and then we take the double, take the absolute value, and store it in a double variable. The next one is double. So you're going to create a double variable that you're going to store the answer in. So POW. POW stands for power. The first number you put in is the base number, some number that you want to raise to a power, and then comma, and then a second number. And that's going to be your exponent, or your power. So 3 squared is 9. So 9 can go in there. Right. So here's in the math class, you do have a random generator, just like in the random class. Double random creates an inclusive 0.0 to uninclusive 1.0, meaning 0.999999. And if you want a larger number than 0 to 0.999, you multiply this result by how big if you want it to be 100, you multiply it by 100. So it would be 0 to 100. Well, 0 to 99.99999. Next method is the double square root. So it's going to take the square root of this number. Now here's the only limitations. This number in these parentheses must be a positive number. There is a lot that we have to add to a program if we want to have the answer imaginary. We're not going to deal with imaginary numbers right now. Kind of like some of you probably know that the square root of -4 is 2i. Alright? So, down here, let's get our objects from other classes. Math class. Math class does not need an object. It is static. And of course, the scanner class is not static, so we need a scanner object. So we have a scan object. We can invoke all the scanner methods using the scan object. Okay. Here are the variables that I've created for today. We're going to have a negative integer, so we can try the absolute value. We have a negative double, so we can try the double absolute value. We have a base and a power, so we could exercise the POW. And we have perfect per square. This means perfect square, so we can use this one. And the double random, we'll just create a variable, a local variable for that. All right. The constructor, we don't need to assign any initial values because we're using the scanner. Okay, we're using the scanner. All right, so let's review the scanner. I've looked at some of your programs. All 4 of you who have done it, I highly suggest you do your homework. All right, so in program, here's the first one. You have to ask the user, you have to prompt them, what do you want? So enter a negative integer and press return. Because it's an integer, we're going to use the method nextInt. We're going to put that in the variable nextInteger, and then we're going to clear the line. Clears the buffer. Alright. Alright, now we're going to ask for a double. Enter a negative double and press return. We're going to use the method nextDouble. Put it in the variable nextDouble, negdouble, and then we're going to clear the line, clear the buffer. Next, we're going to ask for a base, some base number. It could be an integer, it could be a double. Doesn't really matter because you can always put an integer inside of a double. But you can't do the reverse. You can't put a double inside an integer. So in this case, we're safe. If the user types an integer, it'll just auto-cast it to a double. And of course, we use nextDouble. Now we want a power. Power could be a double, could be an integer. Doesn't matter because it's going to be auto-casted to a double if someone does enter an integer. Alright, we're going to use nextDouble again. We're using nextDouble quite a few times. Alright. Now we're going to enter a perfect square. The method calls for a double, so we're going to do nextDouble again. Alright. So now here are all 1, 2, 3, 4, 5 scanner variables that we get from the user. Alright. Now we're going to use scanner input from in our math methods. Alright. So the first one we're going to do is the int absolute value. Now we are going to, in this one, we are going to take a once and done approach. Alright. We're going to print the answer, but we're not going to store it. Alright, what we're going to do is, I want to drop down one line, so I'm going to use an escape sequence. One line down. So this is an int absolute value concatenate. Now, we don't need an object because the math class is static, so we just call upon the class name, math dot abs, and in here we put a negative integer. Oh no, we want our variable. What was the name of our variable? Neg integer. Okay, so that's going to print our absolute value of our negative integer. Now system.out.println. This is our double absolute value. Math.abs neg double. Just to refresh your memory, abs is a overloaded method. It depends on what parameter you put in it. Java will choose the correct method to use. So if you put an integer in abs, it'll use the integer one. If you put a double in abs, it'll use the double one. All right. Next one is we're going to do pow. So we have a base raised to some power. So math.pow. And we have our base, comma, and then our power. Alright, so now we've done our absolute value for integers, absolute value for doubles, and we've done pow. Now we're going to do, let's do our perfect square. System.out.println. This is square root double square root. Concatenate math.squirt. This is our per square. Now, we did not create an instant variables for our random number. So I am going to create a local variable. A local variable's domain, or where its definition exists, is only within the program, the method that it's written in. And because I am declaring it and instantiating it in program, my variable that I create right now only exists within program. As soon as program is done, as far as Java is concerned, it doesn't exist, and that means I could use that variable over again, but I would have to declare it again because Java didn't know it existed. So in this case, we want a double. Double random num equals math dot random right? But I want a number between I want a number between 0 and let's say 100. So I'm going to multiply by 100. So it's going to 99.99, okay? Now I'm going to print it. So this is includes 0, but it doesn't include 100. Random num. I should go fix this villain. There. Random num. Bam. Okay, it's going to be a big long number with a whole bunch of decimals because we didn't format it. Alright, so these are, we tested all 5. Abs, pow, squirt, and random. Okay, those are the key methods in the math class. Let's compile. See if we have a problem. No, I didn't do anything wrong. So now what I'll do is I'll raise this way up here so we can see the output. We'll run it. It says enter a negative integer. Alright, so negative 89. Enter a negative double. So negative 7 point, enter a base. I'm going to do 3, okay, and I'm going to cube it. No, I'm going to raise to the 4th power. Make sure you put in numbers when you test it that you know the answer to. So 3 to the 4th power is 3 times 3 is 9, times 3 is 27, times 3 is 81. We should get 81. Alright, perfect square. Alright, so 169 is a perfect square. The answer should be 13. Make sure you pick stuff you know the answer to. Alright, so negative 89 became positive 89. Negative 7.576 became positive. Base of the power is 81. There's our 13. And our random number was 9.34, blah, 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 blah. Alright, so you have homework that mimics this classwork. Spend the rest of your class time finishing this, doing your homework. Alright?